Hello everybody, welcome to this episode on statistics. In this video, we will be talking about confidence intervals. Before you move on with this video, please watch my last video on margin of error because this video is basically a part 2 of it, and in order to understand anything from this video, you're going to have to go down the description and watch that margin of error video. Let's move on. So let's say that there's a population. You're trying to find a certain mean from that population. You're trying to find the mean of that population. So in order to find that mean of the population, you take a sample and find the mean of the sample. So in order for you to be sure that this sample mean is close to the population mean, you use the margin of error. And your result is as follows: 11.6% to 21.6%. So what does this number actually mean? Let's do a quick recap. 11.6% is your mean minus 5%, and 21.6% is your mean plus 5%. So 5% here is the margin of error. And this overall, 11.6% to 21.6%, that overall is called the confidence interval. And that's what today's video is about. And the 16.6% is the mean. Okay, let's get into confidence intervals width. The goal that everybody should have for the confidence interval width is for it to be as small and narrow as possible. So wait, what is the confidence interval width? The confidence interval width, let's take the same example as before, is the bigger number minus a smaller number. So in this case, 21.6% minus 11.6%, and that gives 10%. So 10% is the confidence interval width, and you need it to be as small as possible. Why do you need it to be small? I'm going to tell you right now. Let's take this example here. Let's say that this is a population, and you're trying to find the weight of the people in the population, the average weight. So you take a sample, find the weight, find the average weight of the sample, and use the margin of error, and this is your result: 20 kg to 70 kg, 44 pounds to 154 pounds. So in this case, the confidence interval width is very big. It's 50 kgs and 110 kgs here. So that's a very big width, and it's almost like you could tell this without even doing any experiment whatsoever. Instead, if you had this as your confidence interval, this makes a lot more sense. Now you actually got information from this: 55 kg to 57 kg, and 121 pounds to 125 pounds. So this is a lot better. Another thing I want to clear out is that you can never have one number as the confidence interval. If you're telling me that you're 95% confident that 56.5 kgs or 123.5 pounds is the average weight of the whole population, then you have to ask the whole population. So you have to gather the data from every single individual from the whole population. And if you have the time to do that, then there's no point of statistics and no point of even finding out the margin of error. So what are the factors that affect confidence intervals? These are the three factors that affect confidence intervals: sample size, population variability, and confidence level. Sample size, I think that's pretty obvious. The bigger the sample, the more accurate the data will be. And when you have more data, the confidence interval will be more narrower and smaller. Confidence level. If you're as the confidence level increases, the confidence interval also increases, because if you're 99% confident as compared to 80% confident, you have to have a lot more data to support that 99%. So if you're saying that a certain average of, let's say, the average weight of a sample, and if you're 99% confident that that is the same as the population, then you have to have a lot more data than being 80%. Population variability, we cannot do much about that, but if the population is more dispersed, if it's more variable, if the quantity is more big and small, then of course the confidence interval will also be much bigger. So there's one way to solve all these problems, and that is with a bigger sample size. Now, how big of sample size do you need? And how much easier would it be and how much better would it be if we actually knew how big our sample size should be and how much data we should collect. And you're in luck because there is a way to do that, and that is with this formula. Now, I do not know about you guys, but as soon as I see this population standard deviation symbol, it hurts my eyes, because usually you do not have the population standard deviation. And I'll come to that in a second. I'll explain the rest of the words first. So Z star value, that is that depends on how confident you want to be. If you're 95% confident, I believe it's 1.96. I'm not sure. Just check the previous video on margin of error. That in that video I show you the Z table in which the Z star values are shown, and MOV is short for margin of error, and that this MOE right here is how big you want your MOE to be. So if you want your MOE to be 5, you have to put a 5 in there. If you want it to be 10, you have to put a 10 in there. And finally, don't forget to square everything. Now back to this population standard deviation problem. There are two ways you can dodge this problem. Either you have to make an educated guess on what the population standard deviation could be, or you should collect a small um, test sample beforehand and use the sample standard deviation in place of the population standard deviation. So if you have the population standard deviation, very good, just put it in there. But if you do not, what I would suggest is that you collect a small sample. It doesn't have to be too big, and you can even use a t-distribution. It has just a small sample as a test. Collect it beforehand. Collect it at start before you even start anything, and then use that sample standard deviation instead of this population standard deviation. So after doing all your calculations, let's say you get a number like 57.7. Always round up, because you cannot ask a 0.7 of a person. So in this case, it's 58. So now in your actual test, in your actual statistical experiment, you're going to have to collect 58 people as a sample in order to get the MOE, the margin of error that you want. And finally, one other thing that I haven't stated in a while is, let's say you're surfing around on the internet and you see a statistical experiment somewhere in the news, and they use the confidence interval. In general, it's just a statistical experiment, and please check if they collected their sample randomly. I think I've said this in one of my first videos. This is very important. This is just as important as having a big sample. Thank you all so much for watching this video. If you learned something new, consider subscribing, maybe give a like. If you want to watch more uh, videos and statistics, check out my statistics playlist. See you all in the next one.